In this exercise, we're going to look at how we set up a block. And in context, a block and a probe site is really the same thing. So on the blue menu, click on blocks, and then on add, and then the screen will appear. We're going to go through several steps. In the first, we want to put in the name and location, then look at the irrigation system, then look at how we handle rain, then the crop type, soil type, and then lastly go to probe. And again, note the red asterisk. Anything with a red asterisk is a required field. So give it a name, preferably something unique, at least unique on this property so you know exactly where it and what it is. You can put a group identifier in, that way you can sort by them and group them together. You can associate this with a water meter and whatever you might call that, water meter 1 for instance. The area is only required if you're going to be using volume for irrigation. And then we want to know the lat long. And to determine that, we can go directly to the dynamic map here. All the sites already in this project will show up in blue, and the one that we're working on now will be red, which will default to the farm location, and then you can zoom into the place where you want to be. So let's assume we're in this cherry block and we're in this row, this many trees in, and note that I can click anywhere and the pin will drop there, and the corresponding lat long will be recorded here. And the lat long again is in decimal degrees. This particular site is in Oregon, United States, and that's why these come up like that. With all that in place, click Next. And now we're going to look at the irrigation system. Up here we want to identify the type of system, either being a pivot or solid set. And solid set would be anything like an orchard, vineyard, anything that stays in place. Or flood irrigation, which would be treated slightly differently. So let's say we have a solid set in this cherry orchard. The system provides for 3 irrigation systems that would be independent. For instance, you could have a drip for primary irrigation and fertigation. You could have a secondary, which is a micro for frost control and keeping the rows green and so on. And you could have a third, which could be overhead for cooling and so on. You want to identify it by type. In this case, a drip, for instance. Put in the gallons per hour, the emitter spacing, and the row width. And then you'll see that this defaults to 33% on the assumption that if this is the type of drip 8 feet apart, it'll probably not cover more than a third of the underground. If efficiency of the system regarded as 90% during the day and 95% during the night. Microsystem could be set up like this, for instance. And note in this case, we're looking at the sprinkler row width, not necessarily the tree row width. So here's a case where there is a sprinkler every other tree row, not in every row. These numbers here we would only use if we're going to be interpolating irrigation sets, and we'll talk about that in a different exercise, but those would be realistic numbers. And then click on Next. We go to the next bubble, which is rain, and we're going to handle rain on what we call an efficiency curve, meaning we're going to make use of only 50% of the rain that falls, but on top of that, the first tenth of an inch that falls we will regard as being non-efficient at all. It'll sit on the leaves and evaporate. And then also, the top limit would be 1 inch, and we can change that number. It might have been half an inch. And this is the maximum we regard that will go into this profile during any one day. And then we go Next. Now we're going to go to the crop type. We have a whole list of preset crop coefficients in here, so we can click on this and drop down to the crop type. In this case, we selected cherry late. Because it's a permanent crop, the emergence is irrelevant. And then we want to know what is the root zone today. If it's mature, it would have the same as the mature depth. If this was a young tree, it might have started out at 12 inches, and then the software will model that from 12 to 36. In this case, I'm regarding it as mature tree and 36. And I go to Next. And here I want to identify the soil types at each level. Now note the red asterisks. I said I have a root zone down to 36. I now have to define the soil down to that depth to be able to utilize that whole zone. There are several ways of identifying the soil. One would be the drop down, select the soil type, and by doing that we're getting the default numbers in inch per foot holding capacity or percentage volume, and then the typical sand and clay classification come in here. And you would have noticed that by doing that in the top one, it defaulted down to the rest. The alternative would have been to use the spall diagram. You can either use these sliders if you know the numbers that you want, or you could say, I kind of know where I am in here with the clay loam. I'm like right there, click it. These will reset, the number will be recorded in here. And when I close this, you'll note that this becomes the default number that I'll be using here. So for each depth, which is probably at each sensor, I have defined the soil type. And the software will make use of that in later calculations. So with that defined, I'm going to go and click on next and then get to the probes. If it's a neutron probe, it'll prompt me for two numbers. If it's an electronic probe, we're going to have a bit more setup to do. If it's a tensiometer, it could be either manual or electronic. We have a hand scale, which is just a visual thing, and if you say none, it'll simply not prompt you for anything else. In this case, let's assume we're setting up a capacitance probe. We'll call that an electronic probe. And then we're going to go into the detail of what it is, what telemetry we have, how we're going to set that up, and we'll handle that in the next exercise.